force and motion. Force and motions. So there are 4 drawers that we're going to create, and this is the story. Don't worry too much about the story for now. Later we will review what the storyline for each drawer. Right. Let me pull out the drawers that you need to create. There are 4 drawers. The name of the drawer are resultant force, resolution forces, equilibrium forces, elasticity. Right. So how do I create the sticker? Just by looking into the name of the drawer. Right. So result is always related to exam. So I create this sticker that is SPM. Okay, so SPM is more related to you. So I'm creating the emotion so that you can remember this easily.
Okay.
SPM is the sticker for the first drawer. So obviously after you took the SPM exam, you got the result. You need a solution. What is the solution? The solution is you will be enrolled into a university. Else you take the exam for what? You take the SPM exam is for you to help you to enroll into a good university. So that is the solution. Solution is university. So then take that sticker of university, stick it on drawer number 2. All right, now we are trying to build the story slowly, right? Now drawer number 2. Then drawer number 3. Drawer number 3 is equilibrium. Equilibrium forces. Equilibrium forces means I take 3 university. So there are 3 university that is fighting to get you to go to enroll into their university because you are the top student. Right? There are 3 university. So whichever 3 university that is in your mind. NUS, University Malaya, Cambridge, it's up to you. Right?
All right.
Right. So there are 3 university. Then because this 3 university is pulling you, that I want you to join me to join NUS in Singapore, to join UM in Malaysia, Kuala Lumpur, and to join Cambridge in the UK. So you are so being pulled up and down and left and right and center. You became a plastic woman. Right. So you're so flexible now. Your legs and arms are so flexible now. You became a plastic woman. So that is to reflect elasticity. So now I think it's very clear what is the story that we are trying to build over here. Yong An, you took SPM exam and you got the result. You apply for university applications to enroll into one of the top universities. And there are 3 universities now pulling you to get you into their university because you are the top student. Right. Then because of that, you became plastic woman.
Plastic woman. Okay.
Okay. So it's easy now. It's easy. So right in front of you, there are 4 drawers. Every drawer have their own sticker. Can you tell me what is the first sticker?
SPM.
Yes. Second sticker.
University.
Third sticker.
Then 3 universities.
Yes. Fourth sticker.
Plastic woman.
Exactly. Right. So first drawer, the name of the first drawer is resultant force. So SPM equivalent to resultant force. Second drawer is resolution force because it's solution. Resolution is solutions. Okay. Third drawer, what's the name?
Equilibrium.
Yes, equilibrium force. Do you know what's the meaning of equilibrium?
Equal is
yes,
like
平衡，平衡，对了 equal, right? So if all forces pull you at the same magnitude, at the same type of force, then you'll be in equilibrium. You don't move. And then elasticity.
Yeah.
Okay, elasticity is clear. I think like plastic, it can be elastic, like a spring.
Yeah.
Right. The rubber band.
Yeah.
Right. So we finish step number 1. So the drawer is created. Like I told you on the last class, my role here is to create the drawer for you. Right. And to start that drawer and to put in some of the items for you to be able to know how is this item related to the drawers. Then towards the end, number 3, number 4, number 5 until number 8, your drawer will definitely different from my drawer and the rest of the students. This is where you need to put your own items in it, right? Now, let's go to step 2. Step 2 is read the keynotes. Let me bring the keynotes out.
All right.
Okay. So this is the keynotes. It's quite long, but it's okay. Let's quickly read it. If you don't understand,
Okay.
it's fine. Yeah, just read it. Let me take the clock out. OK，不用 clock 了，你 anyway 是1对1嘛，你读完了，你跟我讲你好了，我就下来。
All right.
萱萱，你还在吗？
还在。
你 Are you following？
Yeah.
OK，
想问一下 F 是 force right？
对，
OK。
因为永恩姐姐要考 SPM 嘛，所以我会 focus 她多一点，OK 吗？
OK。那读好了。
读好了哈。
嗯
OK，这样我下来去 resultant force，你看啊，this is first drawer。Alright，resultant force 是 first drawer，SPM。
，PM yeah。
OK，SPM，你要记得你要放一些东西进你的 first drawer 一些东西进你的 first drawer。不过暂时我看你们还没，但是如果你可以有这个能力去放东西在 first drawer，这样子更好。如果不可以的话也不用紧，我们等一下慢慢去 create。That is my role. I will try to create that drawer for you. Then later you build up， 这样就比较容易。OK，now second drawer。
University drawer。OK。
这个它有点错了，等一下，我用那个 ChatGPT 给你看一下，会
OK。
比较，因为它那个 equation transfer 过来之后就错了这样看比较容易。
好的。OK。
OK，轩轩你不用担心哦，你还有3年，你现在可以吸收多少就吸收多少。
OK。
OK，好，the third drawer，third drawer 是那个3个 unit 是要抢永安
对，3个月内的。
啊。
读好了。
OK，这个 stage 啊，你不要一直想你要背东西啊。OK，我知道学生现在尤其是亚洲的学生，好像我以前那样啊，都是很怕一看到这种新东西，我就是一直要背，一直要背，要背。You don't at this stage you don't need to have this mentality yet. You just need to pick
OK。
up the keywords, right? For example, triangle, polygon, or forces, just the keywords. You don't need to remember word by word what is the definition of this. You don't need to remember the formula right now. You just need to know there is some formula that's related to sine and cosine. That's it. You don't need to remember this formula.
All
Right?
right.
Okay.
录完了。
Okay, let me scroll down a bit.
All right. Okay.
Okay，萱萱你 follow 到吗
Yeah.
？Okay，你很厉害了你 Form 2报了。你等一下啊，你们等一下，我先把这个东西 copy 出来，放小一点。OK，也顺便你也可以，你们也是读一下，如果 while waiting for me，
Okay.
呀，你可以顺便读一下，然后顺便 associate with the drawer。OK，差不多完了，好完了。OK，那我们等一下可以直接这样 refer。Right. Another thing is, you need to know that I am not a physics teacher. This
Right.
one, I learned physics maybe 2 weeks ago because I am trying to teach my nephew physics as well, just like I'm trying to teach you physics. In fact, the main thing here is I'm trying to teach you how to use BrainDrawer method to learn something. And for this case, will be chapter 1, right? For this, it will be a chapter 1, right?
Okay.
Okay. So in fact, we are learning together using BrainDrawer method. Just that I learn it maybe 1 or 2 lesson in front of you because I've already I have to go through this one time before I can create the keynotes. The keynote is being created by me. The rest of the notes are created by the AI.
Oh.
Right? Okay. And of course, the story is created by me because you need to draw the story out. Okay. So now we finished reading step 2, only reading step 2. But we need to put information or put items inside step 2, inside the story, right? Inside your drawers. So what do we do with that? Okay. Right. For example, 这个东西。等一下，有点乱了，因为太多 notes 了，关掉了。Right. So let's go to drawer number 1. Drawer number 1 现在你开你的 drawer. What do you see? You see nothing.
Empty. Yeah.
You see empty drawer. So
Yeah.
let's see the definition. The resultant force is a single force that has the same effect as the combined actions of the 2 or more forces acting on an object. It is the vector sum of all the forces. If I have to put an item or a story inside the drawer that is reflecting this definition, I will imagine 2 person playing 这个拔河比赛 the tug of war.
Tug of war.
Yes, tug of war. And there is this resultant force. Whoever who is stronger, then he will pull, or he or she will pull the other party together with them.
Yeah.
Right. Okay. So that is the small story that we want to put it inside drawer number 1. Right. For now, Don't, like I say, don't worry about remembering and memorizing the resultant until the forces, right? Usually Asian student especially, when you see this, you want to remember this words by words, spelling by spelling, right? Don't worry about it for now. We just need to know your keywords. So pull that keyword out, and that keyword is that story, the small story. Yong En and Xuan Xuan, you are playing tug of war，在玩拔河比赛 ，right？ Then 轩轩很有力，轩一拔就把永恩拔过来了，right？ 所以就有点好笑，有点奇怪这样的话你就会容易记咯 ，OK？ 所以把轩轩跟永恩放进去 first drawer，right？ Then the second one, the method of determinations. Method of determination, they are same directions, add magnitude directly. Opposite directions, subtract smaller forces from the large one. Perpendicular forces, use Pythagorean theorem. Non-perpendicular forces, right? 这个我要怎么去做一个 story 呢？你看刚才我们不是把轩轩跟永安放进去，现在他们拔河比赛是 opposite direction 嘛？然后这个轩轩跟永恩呢，他们不是只是拔河比赛，他们还高涨哦。他们有时候又自己永恩又跑去轩轩那边自己拔自己，这个就 same direction， 或者是轩轩跑去永恩那边自己拔自己，就拔疯了，明白吗？So same direction 是指那个东西咯。Opposite direction 是很明显了，就是两个人在彼此在比赛。Perpendicular 呢，就是轩轩跑上去，好像会飞的样，他就拔上去天，然后永恩呢就还是在地上这样拔，明白吧？Perpendicular 你明白是什么吗？就是90度
90度明白
90度就是轩轩，然后他会飞的，他现在不是 terbalik， 不是跟永恩 opposite direction， 不，他是飞上去的，他把那个东西拔上去然后 non-perpendicular 呢，就是轩轩他就不是90度了，他什么度都可以，45度也可以，20度也可以，75度也可以，60度也可以 ，OK？ 这样的话，这个 story 轩轩跟永恩拔河的这个 story， 还有这个小小的故事就已经解决了，讲完了这个第一个 part。Alright， free body， 来我们看一下 free body showing only the forces acting on a single object。Right， free body， 我们先想咯，有一个 free body 就好了。free body 是什么意思？就是一个 body 是免费的，是吧？你要不用钱的。OK， 这样把那 free body 放进去，到底是什么呢？如果你现在可以知道了，当然最好。你暂时如果还是不是很明白，不用紧，就是把那个 free body 先放进去你的 second drawer，just put the free body inside the second drawer first for now. Alright. Newton's second law. Newton's second law, what does it mean? Okay, there's a formula. This formula is very important. Force equivalent to mass and times the acceleration. Okay. How do I translate it into an image or an object? Okay, F equivalent to ma. Ma sounds like mommy, right? Mama, mommy. So imagine your mommy is there. You put your mommy inside the drawer, right? Okay. Sounds funny, right? Sounds a bit funny. You put your mommy inside the drawer, lock her in. Okay, lock her in. Right. So that will explain the Newton's second law. Now, so there is a state of motion. There is stationary, there is constant velocity, and there is accelerating, right? So there are three states. Your mommy, when you is locked inside, there are three things that she can do. Okay, number one, she will sit down there doing nothing, crying. Okay, cannot move. All right, imagine your mommy is crying, sitting down there. Okay, that is stationary, right? Number two, she is running. Okay, but she's not accelerating. What's the difference between velocity and accelerating is you are running at the same speed. Same speed. Accelerating is you are running faster and faster and faster and faster. Okay, so your mommy can only do three things. either she sit down there and cry, or she run at the same speed because she doesn't want to because he doesn't want to run faster, and she try to get away from that drawer, and then she found out that she needs to run faster so that she will have the force to open the drawer's door, right? So she tried three things: sit down there and cry, and nobody care, and then try to hit the door with the same speed. The force is not big enough to open the door, so she tried to have a bigger force. That means she's running from 0 to 100 km per hour, and to hit the door, hoping that it will open. Right. So that's finished the drawer number 1. So drawer number 1, what do you have inside? What do you have inside?
Yeah, I drew 4 things. There's the definition one, which is like me and Shen doing tug of war at opposite directions. Then there's the two of us pulling in the same direction. Then there's one where Shen's on the top at 90 degrees. There's one at like 40 degrees, 25 degrees. And then there's a free body. And there's my mom locked in the drawer. She can either be sitting, which is stationary, running, which is constant velocity one, and she can also be running faster, which is acceleration.
Excellent, excellent. So it's easy to remember now. Your first drawer is completed, easy to remember, and that is actually reflecting on somehow this drawer. Okay, somehow this drawer. I think my story is not exactly the same, because this one was done maybe 2 weeks ago. We can create our own story. Okay, okay, we can create our own story. Okay. Now, drawer number 2. Drawer number 2. Drawer number 2 is easy. Resolution of a force means breaking a single force into 2 perpendicular components, usually horizontal and vertical. So you have something vertical, something horizontal. That's all you need to know. If you do not understand, if this statement, this sentence doesn't make sense. If it makes sense for you, excellent. You are on a more advanced stage. But if it doesn't, just pick up the keywords. What is the keyword that makes sense for you? Vertical and horizontal. Okay, let's pick that up first. Right, then let's continue. To simplify analysis, the forces acting at an angle, pulling or pushing objects. So this is the formula. Right, formula is Fx. X is the x-axis, and then the formula is F cos theta. Vertical, this is horizontal. Vertical is Fy is sin theta. Right, sin angle. So if I move this in, resolution of forces, they are Y force, vertical, and X force, horizontal. All right. 2 weeks ago, I do not know what story I want to create. I just create a y-axis and x-axis. Let's say now you want to create a story. How do you want to create a funny story? A funny story. How would you want to create this?
Let's see.
Let's take Xuan and you also, right? Now, oh no. Let's relate it with the drawer. The drawer is solution. Solution, the sticker is what? It's university. University. Okay, now let's take 2 university. Okay. One is on the east, one is on the north. One is at the north, one is at the east. Right. Which university is at your east that you want to go to? University of Tokyo. UM? Okay, University of Tokyo. Let's say University of Tokyo is at the east. East is usually related to a country from the east, and if you think about east, is Japan, right?
All right.
Okay, north. Okay, north of Cheras is UM. Okay, so UM and University of Tokyo.
University of Tokyo.
Okay, so you have a story that you have 2 university. Okay, if you go up, then you reach UM. If you go east, up means north. If you go north, then you will reach UM. If you go east for a very long path, you will reach Tokyo University. Okay, so that is a story. That's a story for this. But how do we add this cost? Okay, cost. Tokyo University is very costly. Okay, Tokyo University is very costly. So you can remember this as F cos theta. You know theorem Pythagoras?
Yeah,
Have you
Pythagoras
know?
theorem. Yeah.
Okay. So 轩轩，如果你不明白，因为你还没有学到 theorem Pythagoras，你学了没有 theorem Pythagoras？
还没有。
还没有 ，OK， 所以你不用担心这个 F cos theta，因为你还没有学到那个 theorem Pythagoras，那个是在 mathematics 的。OK， 不过你现在只要知道这个 Fx 的 formula is F cos theta，and 这个 cos 要怎么记得呢？通常我们都会很 confused between cos 或者 sin。OK， 不过我们这样就很容易记了嘛。Tokyo 是 is 就是 x 嘛，比较贵就是 cos 咯。sin 这个就是 cos 了，上一个下一个就是 sin 了的。OK， 这个很容易记了的。OK，cos 不是 cos 就是 sin， 我们每次就得把它掉好的啊。不过你记得一个，第二个你就肯定记得了。不过轩轩，如果你还是不记得，不用紧，因为还没有到你的 level。OK，
OK 啦，就阿嘎了。
阿嘎也可以，阿嘎就好了。你现在你有3年给你慢慢读。All right, now we are already done. Drawer number 2. Drawer number 2 is very simple. You only have UM and Tokyo University in your drawer. That's it. Close the second drawer. Now open the third drawer. Empty. Nothing inside. No.
Yeah.
So what is the sticker of the third drawer? Do you still remember?
3 universities.
Yes, there are 3 universities. So one university is UM. The second university is Tokyo. The third university is NUS. Right? I think one of your cousin is in NUS. So it's easy for you to link. Do you want NUS or you want another university? NUS is good?
Yeah.
Okay. So because why NUS is good? You see, north is UM, east is Tokyo, south is NUS. That is how this triangle is like three forces, right? At different angle. Right, so that is how you are able to relate this, right? And okay, let's read the definition first. An object is in equilibrium when the resultant forces is zero. Resultant force is zero, meaning there is no net force acting on it. So all these 3 university, the headmaster of the 3 university come and pull you, and all of them are having the same strength. So you are not moving, you are still in thrust. You're still in thrust. Although Tokyo is trying to pull you, UM is trying to pull you, and NU is trying to pull you, but you're still moving. You're still in thrust, right? So there are the triangle polygon of forces, right? So let's read this. Forces in equilibrium can be represented as sides of a closed triangle with direction considered. This one, to understand this, you have to read the textbook because this one it involves some drawings.
Yeah.
Involves some drawings. BrainDrawer doesn't help you to understand the drawing that much, right? So BrainDrawer has their limitation. BrainDrawer is good with text. Okay. Now, solving equivalent problem, you can use trigonometry. Trigonometry can help you to solve equilibrium problem. So you can have two type of method to solve these equilibrium forces, whether you use the triangle or you use the trigonometry. Okay, trigonometry is those sine, cosine, tangents.
Yeah.
Right, I think you know this. So now, what is inside drawer number 3? Drawer number 3, you have 3 university.
Yeah.
And you have, yes, then you have this triangle forces, and you have a trigonometry.
Yeah.
All are 3. You see, tri. All are tri.
Yeah.
Triangle, trigonometry, all are 3 forces. Okay. Now let's go to drawer number 4. What's the sticker of drawer number 4? Remember?
Plastic woman.
Yes, you became the plastic woman. Now you became the plastic woman. So what is the important information that we need to put inside the drawer number 4? So let's read this. Elasticity is the ability of the material to return to its original shape after the deforming force is removed. So now you are the plastic woman. You're like a spring. You put yourself inside. You just imagine that you look like this one. Wait, let me just pull this in. Yeah, now you look like this. Okay, your hand is spring, and your leg is spring, and you are so elastic, right? So you put it yourself in, right? So there's a hook law. Hook law is F equivalent to kx. What is F? F is the force. K is what? Spring constant, the stiffness. How strong is the spring stiffness? X is the extension. How far, how much you can extend it, displacement from original length. Okay, Hooke's law. So you can imagine there's a hook, 一个钩啊，你拿那个钩放进去那个drawer number 4, the plastic woman. 这样 then drawer number 4 you have two things now. You have the plastic woman with the spring,
and the hook.
and then you have a hook, right? You have the hook. Now you have to now read this, and let's see any other keywords that you want to put it in. All right, any other keywords that you want to put it in? I think now, for now, you just need to understand there is something related to potential energy and the factor affecting the K. Don't need to memorize this for now. You need to memorize this later. We will form a story to memorize this later, but don't need to memorize this now. You just need to know there is something related to material type, the length of the spring, spring diameter, or the wire, right? Okay, and that is inside there. So your hand, your legs, the spring is different. All right, some are shorter, some are thicker, some are more flexible. Okay, you just need to know there are 4 types of springs in your hand, and your both hand and both legs. That will be representing this material, spring length, spring diameter, and thickness. All right. Now we finish 4 drawers. Let's review again. Open your first drawer. What do you see inside?
The SPM drawer has me and Shen pulling a tug of war. There's me and Shen pulling tug of war at the same side, the 90 degrees one, 40 degrees and 25, like 40 degrees and all that. And also there's my mom. There's also a free body. And for my mom, there's stationary, like she's sitting there. She's running, which is the moving one, and she's running faster, which is the acceleration one.
Excellent. So close that drawer, keep your mom inside, and open your second drawer.
The university.
What do you see inside?
There's 2 schools. At the north, there's the UM, and at the east, there's the University of Tokyo, which is more costly. So it's
excellent. Close the second drawer and open the third drawer. What do you see inside?
There's 3 universities, which is UM and US and the University of Tokyo, which are all pulling at the same strength, same force.
Yes.
Yeah, same force.
Yes.
And there's trigonometry and also like the triangle.
Yes, there's triangle inside. Good, and trigonometry. Yes. Now close that drawer and open the 4th drawer. What do you see inside?
There's plastic woman. There's me as a plastic woman with like 4 different types of strings, and there's also a hook, which is the Hooke's law.
Excellent. Okay, we have built that drawer, and we have built the items inside the drawer. Now moving to step number 3, read summary. This is where the reading comes. Okay, step 3, 4, 5 will have more readings than the rest, right? But after that reading, your drawer will be filled up with more information or understanding.
All right.
All right, let's do that. Let's open the keynotes. I will have the keynotes next to the.
Okay, I Shen.
先走了。
2点，没有2
哦
点，
2点哦2点 OK OK
2点多8分钟啊。OK OK。诶，这个怎么拿？这个。等一下，要不然我换我的 screen， 换一个比较大的 screen。等一下。这个 screen 应该比较大。看到吗？那个 keynote 是
看
会很小吗？
有点小，
有点小哦，这么大一点。 一个一个拉。这样呢？这样会看到吗？还是太小？
下面有点小，上面
下面我们
的还好。
下面的我们等下拉，我们先 focus 这
OK
个row number one，row number one 看到哦。
draw number 看到。
OK，然后我们先要做的东西就是我们把那个 technique 先拉出来。technique 手掉这个，太多个 page 了。OK，现在我们是在 step number 3，so let's zoom to step number 3。Only to step number 3. Right. So what you need to do is you need to read the notes. Note is on the right hand side, which is this one. Okay. Then you need to identify which drawer or subdrawer, if you already have your own subdrawer that it belongs to.
Alright.
Then identify clearly where is the new information or new understanding. Then place it back into the drawer that you have identified. Like I say, for step 3, the earlier steps, you will find more information, new information rather than new understanding. Towards the end, you're going to see more new understanding than new information, right? If that happens, it's a good sign. That means you're understanding it more and more, right? So I'll keep these techniques over here in case you've forgotten what you need to do. Then you can refer this back, right? So let's do the same drill. Read from this part, ask yourself the same questions. You can refer to our left-hand side, the keynotes on the drawers. Okay, let's start.
Alright.
Okay, okay, what is the drawer?
The drawer number 1. It's the tug of war one, where we're like pulling at the same directions. Yeah.
Yes, the sticker is the SPM sticker, right? Okay.
Yeah, and the SPM sticker.
Yes, and you and Xuan Xuan are doing tug of war. Okay.
Yeah.
So let's continue until the end because, yeah.
Alright. Okay.
Right. If there is new information, put it inside your drawer. Right. Because that new information, whichever it is going to help you to form new understanding later. Now, let's go to drawer number 2. Oh no, drawer number 2, I have to open this also. Okay. Yeah, open it bigger. Yeah, you can continue reading.
Universes. Balances weight. Alright.
Okay, so this is drawer number 2. And there's not so much of, is there any new information?
Not
new
really.
understanding?
It's
more or less the same, right? Okay,
yeah.
good.
For me, some lah.
Yeah, maybe some information, but it's fine. Just have this intention to put it in. Even if you haven't formed the image or formed the story, don't worry. You know that you are putting something there, but that's something you cannot see it yet. Later you're going to use it later. Okay, now go to drawer number 3. Let me pull this up. Okay, you can read this.
I get through it something force. Alright.
Okay, I think this is no new information. Maybe a bit of a new understanding.
Yeah.
right? Okay. Because sometimes understanding you cannot form some object or a story. You just understood it, right? So that
Yeah.
understanding you put it inside, right? Because by acknowledging it, basically you are hammering down this new understanding into your mind already. So by
Yeah.
intentionally know that you are putting something in, you are actually acknowledging it. Okay. Okay, let's do this. Elasticity.
Okay.
Okay, this is drawer number 4, the plastic woman.
Yeah.
What is there any new information or new understanding?
There's some new formulas.
Okay.
I mean, not exactly new, but yeah.
Not exactly new, yes, but is written maybe in a different form. It's somewhere here, right? This one, but it's in a different form. Any other new information or new understanding?
Not really.
What about this one?
Oh. And I thought there was that just now. Or was it not? I don't know.
Was it
I thought I
inside?
read. I thought it was. I don't know.
Okay, yes, you're right. It's here. Right. Rule of
Yeah.
thumb: extension should not exceed half. Right. It should not exceed half
Yeah.
to avoid this permanent deformation. You're right. So there's no new information. There's no new understanding because it's already known. Good.
Yeah.
Okay, let's do this. The last part.
Oh. All right.
Okay, good. So now let's do a recap. Let's do a recap. Tell me again, what is inside drawer 1?
Drawer 1 is the SPM drawer, and it's the resultant force drawer. There's me and Shen playing tug of war. There's us going at the same direction. Shen on top, which is the 90 degrees, 40 degrees one, and also there's the free body. And there's my mom in the drawer, and she's sitting, which is stationary, running, moving, and also running faster, which is acceleration. And yeah.
Okay. The mum is the F equivalent to MA. That is
F equals
Newton's second law. Newton's second law.
Yeah.
Right. So Newton's second law, that means there is a first law. Right. So, but for this case, we do not need to know what is the first law. First law is in the gravitation in Form 4, Chapter 3. So don't worry about that. Let's focus on the second drawer. What do you see what do you see in the second drawer?
The second drawer is the uni drawer, and there's at the north there's university at there's which is a balance, and then there's at the east there's the University of Tokyo, which is costly. So this is the formula, which is the fx is f cos theta, and also fy is the f sin theta one. The formulas.
Great. Third drawer. What do you see inside? What is the third drawer?
The third drawer is the equilibrium forces, which is it has 3 unis. There's the University of Tokyo, the NUS, which are all pulling me, which is they have the same force, which is 0, and I'm just in place. The way to find it is by trigonometry of the triangle, like drawing a triangle.
Right. Good. The last drawer.
The last drawer is about elasticity, which is the plastic woman one. There is a hook, which is for the hook saw, which is I think it was F equals KX, yeah. And there are 4 types of springs. Like that's me as a spring, basically.
Yes, and the spring, you have both your hands and both your legs are having 4 different
four different spring types, which is the materials. I think it was length, diameter, and the thickness or something. Yeah.
Yes, you are right. Actually, you can refer refer to this when you're explaining the drawer. You can refer to this, the keynotes. Right. By referring to this, you are actually reading this again.
Yeah.
All right. So
Alright.
now when you read these keynotes, now we are in chapter 3, step 3. It makes more sense now, right?
Yeah.
The keynotes. Compared to when you first read the keynotes, it doesn't make too much sense. The keynote did not change, like I said yesterday. The keynote did not change. The only thing changed is you are putting in more information, or maybe even better, you are putting in more understanding inside your drawer now.
Yeah.
Okay, good. Now, let's go to step 4.
I need to go now.
Okay,
Bye,
Shen.
Bye
Bye,
bye.
Shen.
加油. Bye bye.
Thank you.
Bye.
Bye.
Bye bye.
Okay, we will continue step 4, FAQ.
Alright.
Read the FAQ. So same drill. If you've forgotten what's the drill, then you read the techniques. All right, else, let's continue.
The forces. Okay.
Okay, I'll scroll down.
Direction.
Okay.
Direction. Alright.
Okay, this is clearly which drawer?
The first drawer, the SPM drawer.
All right, good. So let's go to second questions. Do the same drill.
Okay. Integrity and safety. Okay. Okay.
Okay, so any new information or new understanding?
Oh, there's the concept, like the integrity and safety of the structures.
Yes, yes. And also now it's telling you how do you apply the forces
in real life.
this real life, like Langkawi Sky Bridge.
Yeah.
Right. Okay, so now there's new new understanding, not information, into your first drawer now. So your drawer is becoming more and more crowded. Right. And your, like I say, your drawer and my drawer and Shen's drawer will be totally different.
Yeah.
At the end of this method. Okay, now continue on the next questions. This is drawer number 2.
Functions, rates and force. Incline. Okay.
Okay. Any new information or new understanding?
A bit of new understanding, I guess, at the incline, as an incline. Yeah.
Okay, so there's new understanding. That's good.
Yeah.
Okay, number 3.
Triangle. Those triangle. Okay.
So this, which drawer is this?
This is the third drawer, which is the 3 university one.
Good. Okay, now let's go to the next questions.
Okay. This one is the plastic one. Yeah.
Yeah.
Small. Only within the elastic limit. Okay.
Okay, so maybe this is a little bit of a new understanding.
Yeah.
Or solidify your understanding. Okay, I think it's wrong. This formula have to delete one of the alphabet. All right, so go to the next one. This one. This is done. Or yeah.
Yeah. This one's
done?
the yeah.
Okay.
material, the length, diameter, wire thickness.
Okay, how do I remember this material, length, diameter, and wire thickness? Okay, let me open the, yes. So how to remember? It's very funny story. So this is you are the Captain Hook. And this Captain Hook, you have your left arm is gold, made of gold. Your right is made of silver. This is to describe the material.
Different materials. Gotcha.
Yes. And your left arm is shorter. Your right arm is longer. So this is to describe the length.
Length.
Okay. Now I finished talking about the arm. Let's talk about your leg. Your leg, one is having bigger diameter. One is having smaller diameter. This is the bigger one, bigger diameter, and smaller diameter. Right. But the one that is having smaller diameter is having thicker. Thicker. Right. Thick and diameter bigger is different, huh? Right? Thicker.
Yeah.
Right. So just imagine, just if you can memorize or understand this picture, you're already able to understand the factor that is affecting the spring constant. You don't need to memorize this MA until lower K.
Yeah.
Right? Yes, usually, normally, if an Asian student, you will do this MA until lower K for 200 times, and then and then you will take maybe 3 hours or 1 hour just to memorize this. But after 3 days, I'm sure you forgot most of them.
Yeah.
Yes, but with this picture, this funny picture, which is not logic, I think you remember this very easily. Just 2 seconds, then you remember this. Gold, silver, long, short, big diameter, thicker.
Yeah.
Done. That's it. Okay.
All right.
Now, let's go to continue. Continue on this. The last one.
Okay.
All right. So we completed step 4. We've completed step 4. Let's move to step 5. Step 5, you have read guide and quiz. Right. This is the technique. If you've forgotten the technique, this is the how you're going to do that. So I'll go to the guide first. Okay. The read guide first. So let's do the same drill. Forgotten the technique, read from here what you need to do. And what is the skill that we are trying to train here is also important. Okay, then you can start. You can start from here.
Okay. Salary. Okay.
Okay.
All right. Yeah.
Scroll down a bit. Yeah, until here.
Not open. Okay.
Okay. Do you feel that now this formula doesn't feel so scary now?
Yeah, because it's linked to like the drawings. Okay.
Yes. Doesn't feel the drawers, not drawing, right? The drawers.
Yeah.
All right. Doesn't feel so scary now because you already know the concept. You know they are the same direction, opposite direction, and it's very clear. Same direction, of course, F1 plus F2.
Yeah.
The opposite direction obviously is minus.
Minus, yeah.
Yes. Then different direction obviously is depending on which angle. Or
Yeah.
theorem Pythagoras, right? Perpendicular and non-perpendicular, right? So it's not so scary. If you do
Yeah.
not have the concept, if I first look at this, it looks very scary. I don't even know what you're talking about. And then what you do, you try to memorize from FR until this FX without understanding this. Okay. And the problem is, even if you memorize, you cannot answer the question because you don't know what is this. And another bigger problem is you take 2 hours to memorize this formula, and the 2 days later you've forgotten them. So you're just wasting the 2 hours. Okay.
Yeah.
Now, let's go to drawer number 2. Sorry, I'm not sure whether you realize that whenever we move to drawer number 2, I also move this part. I also move this part. Do you realize?
Yeah.
Do you know why I move this part?
So you can see the difference.
So you can, yes, you're right. So you can refer. You can refer, you see, okay, oh, maybe there is some new information, or maybe not. Then I'll refer back. Oh, yes, it was there. So it's not a new information.
Yeah.
Okay. Yeah.
All right.
Okay, good. Let's go to number 3. This is here.
Okay. Gradient action. All right. Excellent. Okay.
Right. Let's focus this a bit. Now with that picture, you still remember that picture, the spring picture?
Yeah,
of
the
yourself?
string.
Right. So it's now this is not so scary anymore. You don't
Yeah.
even need to memorize them. Now you understand them by heart already. Right. Material, length, diameter, and thickness.
And the thickness, yeah.
Yes. So the next thing that you need to know, if this is a new information or new understanding, the stiffness. How is it affecting the K? Different material with different stiffness, which is highest the stiffness, then the K is higher. If the spring is shorter, then the stiffness or the K is also higher. If the the diameter is smaller, then the K is higher.
Higher.
If the spring is thicker, then the K is also higher. Okay? Now, let's go to the quiz.
Okay.
All right. Quiz, I changed the format a bit. I think this is better format rather than keep moving up and down with the question and answers.
Oh.
But you have to intentionally do this technique also, right?
All right.
Before reading the answer, do this. Read the question and then think: is there any information that you can pick up from your drawer or these keynotes to form this answer? Okay, let's do that.
So this is the first round one. Magnitude, state of motion. Oops. No. This is, yeah, okay.
Right. Then you can read the answer if you haven't.
Okay.
You ready?
False that represent the values on all forces, it cannot check. Okay.
Right. So this is to the same drill to pick up new information or new understanding. Now you should have more new understanding than information. If you still
Yeah.
now having more new information, then maybe you are not focusing on
Didn't
the
connect
previous
together.
steps.
Yeah.
Yes. Or if now there's no new understanding and no new information, and that is even better.
Second one. Second one, horizontal. Each one. All right.
Okay, let's do the answer.
Okay.
Okay. Next.
Oh, equivalent process. It's simple seven. Yeah. Third one. About resting. All right.
Okay.
Okay.
Okay, let's do number 4.
That's the elasticity. It's first statement. Okay.
Okay, let's do the answer.
Space at extension of strength professionally. Only if it's not stretched beyond. All right.
Okay, let's do question 5.
Inconstance is. Yeah.
Okay.
I can hear your song.
You can hear her?
Oh no, like my brother was watching something and I can hear I can hear the audio.
Okay.
Yeah, I can hear what you're listening to. What is it? Okay.
Okay. Question.
In triangle forces. Forces. Okay. All right.
Okay. You finish the answer or you
Yeah,
form your
I
own
finished.
answer?
I think of how I would explain it, and then I see if
Okay.
it's similar to the answer.
So okay, good. You did not do the shortcut, huh? You need to do this. Okay, you need to do this. Okay, right.
All right.
All right. Question number 7. That is drawer 1.
Everybody, this is the first drawer.
Yeah.
Isolate. Everybody. Okay.
Okay. Answer.
helps find Newton's laws accurately. All right.
Okay. Almost there.
Uniform velocity. That's the first, the first one. This one, I think what is this imply acceleration is 0? Yeah. Okay. Yeah. Okay. Implies acceleration also 0. Yeah. Okay. These two factors, all factors. This one is the fourth one, which is the test of spreads. Yeah.
You know more than 2. You know all the 4 actually.
Yeah.
And you can easily write down all the 4.
Material, yeah, the diameter, thickness, and the length.
You know,
The
before you go to the last one, let me tell you a short story. I use this method to teach my niece, which is Form 1 at that time. She says before this technique, she was having difficulty to answer the questions. And after this technique, she has a new problem. She doesn't have enough time to write down all the answers. Right. I told her this is a good problem to have.
Yeah, that's a good problem to have.
Yes. I think this formula is wrong. Okay.
What happened?
Yes, but let's do that first. Do the question.
Yeah.
And then you get your own answer. I think you know the answer now.
Yeah. The K X and also the EP on relation. The potential. Yeah. Okay.
Okay. The spring, there's one point I think is important, is the series and parallel.
Oh yeah.
Right. If you arrange them on series, then the K is weak. If you arrange them in parallel, then the K is stronger. Do you get that knowledge? You got that right?
Yeah.
Okay. Why this is important? I think this is important when they are asking some normal questions, ask you to do some calculations, or ask you to do some prediction. Okay, prediction. Which one is stronger? Which one is how to make it stronger, or how to make it less strong, weaker. Now we've completed the difficult part. Now is the easier part. Step 6, which is watching the video. As you know, watching the video, I have a technique. The technique is you need to always intentionally link the content of the video to which drawer.
To the drawers, okay? Yeah.
All right. Why do we want to do that?
So no flying brain.
Yes, no flying brain. That's not point number 1. Point number 2 is by intentionally linking it, you are actually building these 3 trainable skills that we to differentiate it from the B version of yourself to the A version of yourself. Okay? Okay, let's do that.
All right. Is that supposed to be sound? Okay. Sure. First box. Yes. University box. Social force. This is cancel. This is the third box. It's 3 units. First triangle. Horizontal first. Oops. Yeah, looks like. Mm.
All right, so think about it. The chair that you're sitting is in perfect equilibrium. If not, then you'll be falling.
Yeah.
Yes. So the next step is to listen to podcasts. Then let's open it up first. And also we have the techniques.
Welcome to the deep
Oops.
dive.
We also have a techniques. The technique is, let's put it on back first. Yeah. The technique is also the flying brain problem. To reduce the flying brain problem, we need to intentionally to link it with the drawers that we have created. This node is not the correct one, so let me just pull up. Yeah, pull up this one.
Right.
I'll pull up this one. Hey, where is it? Yeah, I did not use the one just now because the one just now with the formula is a picture, so I cannot highlight. So I'll use this one that is not perfect with the formula, but at least I will be able to show you which drawer that it is pointing to. I think that is the most important, not the formula,
Right.
right? Okay, so
Okay.
while we are listening to this, you focus on which part that I'm highlighting, and that is the linking to the drawer. Okay,
All right.
let's do that. So how long is this? It's about only 4 minutes, less than 5 minutes. So let's commit to yourself, focus on these 5 minutes, and do not do anything else. Do not check your WhatsApp. Do not think about what to have for lunch. Do not think about anything else. Okay,
Okay.
let's do that.
Welcome to the deep dive. Today, we're looking at something pretty incredible, the Langkawi Sky Bridge in Malaysia.
Oh, yeah, that one's amazing.
Right. 125 meters long, curved, hanging way up there, held by just 8 cables from this one, sort of tilted pylon.
And it's perfectly stable. Seems impossible.
Exactly. But it's not magic, it's physics, the kind of fundamental stuff you're likely covering right now if you're around, say, year 11.
Mm-hmm.
So our mission today is to dive into force and motion 2. We're talking resultant forces, resolving forces, equilibrium, and elasticity.
Basically, the physics behind why stuff moves or stays put and holds together.
Yeah, the principles engineers use for everything from bridges like that to, everyday objects.
And it starts with this idea of a resultant force.
Hmm.
It sounds complicated, but it's just the single force that sums up all the pushes and pulls acting on something.
Like in tug of war.
Exactly like tug of war. If the teams pull equally, the flag stays still.
Right. Balance.
So the resultant force is 0.
Yeah.
But if one team pulls harder,
The flag moves towards them.
the resultant force isn't 0 anymore, and you get acceleration in that direction.
So 0 resultant force means stationary or moving steady.
Or moving at a constant velocity,
Yeah.
No acceleration. Any resultant force that's not 0 means acceleration is happening. It's a direct prediction.
Okay, that makes sense for straight line pushes and pulls, but what about forces at an angle? Things get trickier then, don't they?
They do, but physics has a neat way to handle it.
Like in that Turek Ape game you see sometimes, where someone pulls a friend on a palm frond.
Perfect example. The person pulling is pulling upwards at an angle.
But their friend slides horizontally along the ground.
Right, because that single pulling force is actually doing 2 things at once. It has a horizontal part, a component, that makes the friend move forward.
Okay.
And it also has a vertical component pulling slightly upwards, which helps kind of lighten the load against gravity.
Ah, so you break the force down.
Exactly. We resolve the force into its horizontal and vertical effects using trigonometry. FEX, F goes theta. The ACE, FE, F sin theta. You know the drill.
Right, I remember seeing those.
It lets engineers analyze much more complex situations, like all the different angled forces on that sky bridge.
Which brings us back to equilibrium. You said that's when the resultant force is 0.
Precisely. And that's the secret to stability. An object in equilibrium isn't accelerating. It's either perfectly still or moving at a constant velocity.
So the Langkawi Bridge, despite the wind, people walking on it, its own weight. It's
Yeah.
all balanced.
Meticulously balanced. All those forces, wind load, the weight distribution, the tension in the cables, they all add up vectorially to 0. That's equilibrium.
Wow.
There are even graphical ways to show it, like the triangle of forces. If three forces on an object make a closed triangle when you draw them tip to tail,
And they balance out perfectly.
they're in equilibrium. Yeah. Understanding this is just critical for safety in any structure. It's the reason things stand up and don't fall down.
Okay, so equilibrium is about balanced forces. What about the materials themselves, like how things stretch and bounce back? That's elasticity, right?
That's elasticity. It's the property that lets a material return to its original shape after you deform it and then let go. Think springs, rubber bands, sponges.
And there's a law for springs, Hooke's law.
Yep, a really fundamental one. F equals kx.
F is the force you apply.
X is how much the spring stretches or compresses.
And K.
K is the spring constant. It basically tells you how stiff the spring is. A bigger K means a stiffer spring.
And does that K depend on the spring itself?
Absolutely. It depends on what the spring's made of, its length, diameter, even the thickness of the wire. It's all baked into that K value.
Interesting.
And when you stretch or compress that spring, you're storing energy in it. Elastic potential energy. Like cocking a mechanism.
Which you can calculate too.
Yeah, EP is half APAS, or half KX squared. It's energy stored, ready to do something when released.
So putting it all together, resultant forces tell us about motion, resolving forces helps with angles, equilibrium is key for stability.
And elasticity describes how materials respond and store energy.
These really are the building blocks, aren't they? They explain that incredible sky bridge, but also everyday things.
Absolutely, from bridges to bike suspensions to, well, almost everything mechanical.
It shows that building something amazing like the sky bridge isn't just guesswork, it's deep understanding.
Deep understanding of these very principles.
So thinking about that, what kind of future structures, what cool things might you listening imagine or even help design now that you're getting a handle on these powerful ideas of force and motion? Something to think about.
All right.
All
We
right.
finished step number 7. Now, does physics sounds more interesting than before now?
Definitely.
With these
Before I-
applications? Yeah, with the application, I think only these 2 chapters, it tells us that a lot of things that happen to us, the chair that is not moving, the Langkawi Bridge, how it was being designed, and the
Yeah.
forces. How do you kick the ball? How do you do the spring? Why spring is there? And move to chapter 7. How is the solar panel is being designed? How is this automatic sensor door is being designed?
Yeah.
Yes. And what is this Einstein theory that we always think about this, but never get to understand what is this? And now all things are becoming clearer and clearer. And not only that, you're able to associate them with what you're facing or you're working on it now, right?
Yeah.
So that will create interest in that subject. Obviously, if you do not know all this and you keep reading 200 hours and you still do not understand half of it, that will demotivate you from learning more, right? That is why some of the students will say that they hated physics, right? And that is the reason. It's not because they hated it. It's just because they did not find the right method to learn it, right? Okay.
Yeah.
So I think this is chapter 1 for step 7. The last step is creating the story.
Yeah.
Creating the story. So this I've already shown this to you, but I can just explain this quickly. Then you can understand the full story behind this. This story might not be exactly relevant to what we have created just now for the past 1 hour. And in fact, we only did 1 hour. It's not even 2 hours. Number 1 is you have already run through this. You know the drill. Number 2 is this chapter is relatively easier than quantum physics because quantum physics is much harder. And and that's the reason you can do it in 1 hour, right? Now, before I go into the story, 1 hour. What can you do in 1 hour? You can choose to scroll your TikTok and Facebook, and easily you will spend more than 1 hour. Yeah, but you choose not to do that. You intentionally make that choice to come and sit here and listening to me talking about chapter 1. And with that, the result is now you understand chapter 1 much more than 1 hour ago. I hope that's
Yeah,
true. Is that true? Yes.
that is true.
Yes. And I hope that with that, you also have more interest into physics, much more than 1 hour ago.
Definitely.
Yes. Okay. So let's go into this story. The story of this, when I first created this, is it's not about SPM. It's about my niece and nephew walking to the school, and then okay, we can change this story. Okay, this story is the niece and nephew go to the school and sit for SPM. That's where you are able to relate the drawer with SPM.
Drawer. Yeah.
Yes. Then the university, I did not put that in because that story was not related to the university. I think we have university. No, the SPM. Wait.
University was the second drawer.
Yeah. I think yes, the same direction, opposite direction, perpendicular direction. This, why do I have this? Is because my niece, the Cheche, she went to Singapore and study after the SPM. So she fly away. So she fly up. So that's how the perpendicular forces comes. And then the TT who is still in KL, then he was lying down on the sofa with this angle and resting. So that's how I describe the non-perpendicular force and perpendicular force, right? You can have your own story. This story is just like 2 weeks ago I created this story, and now I created another story. Tomorrow, if I do the same thing, maybe I'll create another story because that story is really it can be very flexible, and it can have many other options depending on yourself. Then this is a mummy. I draw the mummy, and the mummy is running. So that was to describe the mummy. Yeah, the acceleration. Right. Why I draw this very funny body is because it's a free body. Yeah, funny story. It's not funny body represent free body. So that's what I was thinking at the time. Right. So that's helped me to understand the drawer number 1 with just these few pictures. Right. Then the resolutions. The resolution, like I say, I do not know what story I can create. I just put the Paxi X and Paxi Y, X-axis and Y-axis. But today we created University of Tokyo. It's more expensive, and we created UM is at the north of your house.
Yeah.
Then here, I was creating the story of the Cheche. There are 3 boys wanted to go after her. So Simon, Chris, and Tom. Simon equivalent to sine, Chris equivalent to cosine, Tony equivalent to tangent. Yes. Yes. So you can use the same story, or you can use your story, right? You can use your story, which is University of Tokyo, NUS. I think this story makes more sense because you have the sine, which is the S.
You have the sine, cos, and the tangent.
Yes, the Tony is the tangent. The Chris is the cross. Is the cos. Then so this is the story number, drawer number 3. Drawer number 3. What else do you have in drawer number 3 that I missed? You have trigonometry. This one. Yeah, the triangle. The three arrow is already representing the triangle and also the trigonometry. That's how I do it. Trigonometry also is represented by the Simon, cos, and tangent. Right. Then the next story is the elasticity. Elasticity is the same story, yourself, which is called yourself Captain Hook. And this Captain Hook is having different arms, different legs. And for the arms, you have made by gold and made by silver. That is representing the material. And one is shorter than the rest or longer than the other. So that's the length. Then you have the diameter, and then you have the thickness. So that is to tell you the elasticity, the K constant. Then I put the series and parallel. That is to remind me that the series is weaker, the parallel is stronger for the K. Okay. Right. So that conclude chapter 1. That conclude chapter 1. Let me see if I can create that MCQ. Do you want to create the MCQ to test yourself?
Yeah.
Yeah, let's do that. I don't have chapter 1 here, so I have to take some time to create it. Meanwhile, you can also see how I create it. So this is the entire textbook. Chapter 1 is, I remember it was page. I should not open it yet. Let me close this. Let me do it my way first. Open it in Chrome. Until I remember it was 47. Yeah, 47. So you have 37 pages. What's the 10 until 47. T5C1. Force and motion. Okay, let's go to one of my chat here. All right, let's move this aside and bring that picture in. Because imagine you are in the exam right now and you already trained yourself to draw the picture, and you have drawn the picture before you start the exam. No, you draw the picture before you when you go into the exam hall. Can you draw the picture in the exam hall? Can you draw a picture like this when you're having exam?
Yeah, I'm pretty sure, yeah.
Yeah, I think it's last time I can. Now I think still can, right? Right. So this picture you have drawn it using less than 1 minute, and now you can use it to refer. Okay, and now you're in the exam. Read the question. The same drill. Read the question. Tell me which drawer. Then tell me the answer.
The first one is the first drawer, and the answer is B, which is resultant force. And the second one, if the two forces of 8n and 6n are in the same direction of an object, the resultant force is 8 plus 6, which is 14, so it's donkey.
Okay, it's the first drawer, right?
Yeah, it's the first drawer. It's the one where me and Shen are pulling in the same direction.
Yeah.
The next one is the second drawer, I'm pretty sure. And let me read. A block is put by a force F at an angle above the horizontal. Horizontal component of F is horizontal, so it's force. Yeah, it's
Tokyo.
Yeah, it's Tokyo, so it's B. Yeah. Which of the following best describes forces in equilibrium? This is the third one. Wait. So it's, let me read. C, zero resultant force. They're three all pulling at the same force. Yeah. 5 Hooke's law, which is the fourth one, which is the plastic woman one. According to Hooke's law, extension of strain is directly proportional to law is, I think it's thickness wire. Is it B?
I don't know.
Hold on, let me think.
Hooke law. You remember the?
No, yeah,
formula?
it was the formula was K equals to F over X. You know, F equals to KX. Which one?
So what is F? What is K? What is X?
F is the force, K is the stiffness, and X is how much it stretches. So I think it's C. 5 is C? Yeah. 6 when the spring is stretched. It's B, 1 over 2K X squared. Resultant force at an angle of is not 90 degrees. 7 is wait, is it 7? Yeah, it's 7. It's the first, it's the resultant force, the SPM box. Which one uses non-90 degrees is the B, the triangle of forces. Number 8, a vase rests on the table. The upward normal force from the table is equal. Oh, this one is the this one. Yeah. Newton's third law. I'm pretty sure. I think so.
Newton's third law? You sure? Which
Yeah,
drawer
I
is
think
it?
this one is the. Where's the equivalent force? Hold on. C is. Hold on. Yeah, C is relevant forces in the equivalent. It's like a perfect equivalent, like the chair. It
So
is. I think it's C. I think it's the third drawer, right?
Yeah, the third drawer.
Yeah.
Equilibrium.
Yeah, so it's C. 9. If the extension of a string is plotted against the applied force, the graph is a straight line through the origin. Graph straight line through the origin. I think this one's the fourth box, is it? The fourth one.
I don't know, you tell me.
I think it's the fourth one, and I think it's V, the string of Hooke's law. And then the 10 is F equals to ma, which is the first one, resultant force, the SPM story. So it's A, 10 is A. Yeah.
Tell me my score. Let's see. How many do you get? Oh,
Yeah.
10 out of 10. So you understand the topic very, very well in just 1 hour. Obviously, you studied this before, but this is helping you to understand it better, I hope. Right.
Yeah.
Yeah. And another thing is, I think I mentioned this yesterday or 2 days ago also, that when you answer this question, 1 to 10, you are not so much of a guessing.
Yeah.
You are quite sure which is the answer. Compared to before, most of the question or some of the question, you are not so sure, you are guessing.
Yeah,
Right.
definitely.
Yes. So that is also another way of showing how well you understood the chapter. And by this, moving forward, you try to answer the question that is with another format, like structure format, like essay format. I believe you will also be as confident as what you are doing right now, like answering all these questions. To answer all this, to answer the rest of the question, like the structural question or the essay questions, right? Next, you just need to be familiarized with those questions, and that's it, right? And every time when you answer those questions, I'm sure you're gonna get new information or new knowledge.
Yeah.
Right. Then that's it. I think then you're done with chapter 1 and chapter 7. You just need to continue revision it, right?
Yeah.
So we'll try to arrange the time. Maybe we can continue for the next few chapters. Any particular chapter that you would like to focus?
As a matter of fact, yeah, some chapters. Wait, let me check my. I think it was like chapter 4 and 5. I think I'm not really good at the electrical stuff.
Okay, chapter 4 is the electromagnetism. Chapter 5 is electronics.
Yeah.
So
sometimes I get
chapter
confused with the formulas.
Okay, so electromagnetism and electronics, right?
Yeah.
Electromagnetism is talking about how you use the magnet to generate electrics.
Yeah.
And also the transformer. Right, the Fleming right-hand rule, Fleming
and the left-hand rule.
rule.
Yeah. Sometimes I confuse these two.
Then Lenz's laws, and then the transformer of the solenoid. Those things, right? Okay. Then the electronics are the diodes, semiconductor diodes, the transistor, and also the what's the last one? Let me think. And also the transistor diode and one more. I can't remember also. Let me see. Let me see my. I'm trying to challenge myself to see whether I can still remember, because I I read this 1 week ago.
Mm.
This is electronics. Yeah, transistor or electron, semiconductor diode and electrons. Electron is drawer number 1, semiconductor diode and transistor.
Mm.
Yeah. Okay, so this is the story.
Oh.
Then the electromagnetism, this is the story. You have 3 stored drawer: motor, generator, and transformer. Okay, all right. So let me do some homework. I have to do this this homework that is the keynotes to rearrange. And then we can start with chapter 4. Then I'll tell you what's the time.
Okay.
All right.
Thank you.
Okay, have a nice day. Bye-bye.
Thank you. Have a nice day. Bye bye.